scenario if the value for street 2 happens to be null. So if I continue running this test, which obviously doesn't get any further, but if I did, then this code would be fine. The key thing is that when I go here and I do a dot length, it should issue a warning if I've not gone ahead and set street 2, or at least done a check. And the result is, in this code up here, when I dereference street 2, the compiler says, wait a second, I don't see any check for null, this is a possible problem, and will issue a warning, which is exactly what we want the compiler to do. Now, could it be an error? Could the compiler issue an error? And the answer is, if it did, none of your code will compile. So at best, we can issue a warning that perhaps this isn't null. And the feature that we're introducing with nullable reference types is the ability to specify explicitly that address string 2 could possibly contain null. But street 1, city, zip, and country are declared as not null explicitly. And you hear what I'm saying, right? Explicitly, those four properties are declared as not null. And I'm changing the meaning of string for all time C#8 and later. And what I'm basically doing is setting us up for the future to make sure that we use the type correctly. But we're going to go through a transition period where the value, where we're going to get a whole bunch of warnings.
Question?
Yes?
Under that, go back. Under that, could I still initialize street 1 with a null string?
The question was, can you initialize street 1 with a value of null? And the answer is yes.
Like that?
Looking for an example. Like this right here, you could. But you've said that text is not null. And therefore, I as the compiler can say to you, really? Are you sure? And you can say to the compiler, I'm a programmer, I know what I'm doing. Or you can say, oh, it's telling me this because there's likely to be a problem and I need to fix my code. So can you? Yes, because I'm only issuing warnings. I cannot do anything more than a warning. And you can choose to turn the warnings off. You can choose to ignore the warning. Or you can choose to fix it and say either declares text as string question mark, a nullable value, or don't. But don't write a line of code that's saying this is not null and then assign it null. And I would argue that's exactly what we want. Now, in this code here, I'm assigning string text, string question mark text. Now, it's a nullable value. I go ahead and assign it street 2. What do you want to have happen here? Allowable or not allowable? Warning or no warning? I get a yes, but I'm not sure what that means.
They're both no warning, correct?
You want it to issue a warning, but of course you still want to allow it, right? You are assigning a nullable type to a not nullable type, which is allowed, but cautionable.
Well, the code you're showing does allow that.
Right, sorry, you're right. That was the previous thing. This one is totally allowable. Sorry about that. Thank you. I'm sorry, that's why pair programming is so important. This is the ultimate. Correct. So if you go in this case, go string, see the problem with using text in two different functions, that's really confusing. Who wrote this? In this case, we're saying street 2 is nullable, and we're assigning it to a nullable type, no problem. Okay? But then, in the next line, we do text.length. Is that allowable or cautionable? Is that cautionable or not cautionable?
Questionable.
that should be, we should get a warning.
Yeah.
If we do a dereference of text and text is nullable, we should get a warning. In the next case, we check for null, and then at the bottom, now here, do we want to go ahead and issue a warning for this code?
No. No.
No. We're saying check for null. If it's null, return the default of this value type, which is null. No problem, that works. So there is no warning here. I've explicitly said check for null before going ahead and invoking length. Yes?
On line 60, you have integer question mark, right? So you're saying that I'm expecting it to be unnullable integer.
Yeah, so the problem is the error doesn't happen in the return from .length. .length returns an int, and if I invoke text and text is null, the exception occurs there. Right? Here, this is going to be an exception if text is null. And text could be null because street too could be null. In fact, it is null. So I want a warning right here. Now, if I put a question mark there, which is what I did down here, we're good to go. But if I don't put the question mark in there and put the Elvis operator, we're saying, I should get a warning. I'm probably making a mistake here, or I'm likely making a mistake, or it's possible that I'm making a mistake. Yes? No.
I was hoping the compiler would be smart enough to understand that I'm expecting, because it's a generic, I'm expecting it to be null.
So, here's the issue though.
But then a null doesn't have a length property.
Let's just look at this line on its own. Let's introduce another problem, just for the fun of it. No, it's not. I didn't put a variable type in there, sorry. So in that case, if the exception is going to occur, when does it occur?
On the right.
When I dereference. The same thing is down here. When would the exception occur? When I dereference. It doesn't matter what I'm doing with it. The exception's already occurred. On the other hand, if I did this,
Text.
should that return, should that issue a warning?
Does it need more parentheses?
Oh.
No. No?
It should be compiler error, right?
Why?
Because you are saying integer question mark and you are comparing with null, right? Oh, maybe you don't. Okay, that's fine. Ignore that.
If we're going to implement this feature correctly, and you look at your existing code, you have written your existing code correctly, and you are checking for null before you dereference. That's what your existing code does in C# 7.0.
Your test will fail, but
Details. Your existing code today checks for null, then dereference. And if you do that, and we still issue a warning, you're going to have way more stuff to clean up than necessary. So what we need to do is we need to do static analysis on your code such that if you have checked for null and then dereference a nullable reference type, we do not issue a warning. And that's what static analysis does. The thing to note is that the compiler is not making any guarantees. The compiler, you could do stuff that the compiler doesn't know, and the value could still be null, such as multi-threading. And there's nothing I could ever do in a compiler with static analysis that could prevent that from happening. But I can give you an indication that it's less likely and I can not issue the warning because most of the time it didn't change.
Question?
Go ahead.
If you explicitly mark the variable as being volatile, would the compiler still give you warning?
So the question was, if we go explicitly mark the variable as volatile, can this compiler still give you a warning? And I think the answer is no. We're still not going to handle this scenario because we have the exact same problem. It still could change. It doesn't help us. Yes.
So the real problem I see is when you're writing an API or accepting parameters from somebody else, you look bad and you get null reference exception and then somebody else passes you null. So the thing that would be nice to have is just say automatically declare function saying, look, if anything's null, it'll issue your argument range exception or bad some other nice exception that makes the caller look bad, not me look bad.
Yes. So the feature request is that when somebody else does something stupid, they won't blame me. Pretty close? Yeah. Okay.
Otherwise you got.
But let's think about it. Imagine if somebody calls your perfect API and you have gone ahead and declared a function that takes a string, not a string question mark, but a string. And they invoke your function and they get a warning saying you are explicitly passing null, or we think you might be passing null in this case. And they go, well, that's nice. Let's see what happens. And you can go, but, all you like, but you're still going to have to check for null.
So you got a bunch of boilerplate.
So the reality of it is, this does not allow you to write APIs that hope everyone else does the right thing. Because it turns out it doesn't change people's personalities. That's a great idea, though. I'll submit that. You understand the problem, right? You understand the problem. The problem here is that we can't prevent people from doing stupid things. Even if we issue warnings, they could ignore them. Now, most of us, I would expect, are turning on warnings as errors. At least in our build systems to make sure that they aren't slipping through. But you don't know what your customers are doing. And you certainly don't know what the other people calling your API are doing. So it turns out that unfortunately this does not guarantee. We are not inserting an attribute like contracts did. We're not inserting something that magically says check for null before I dereference. In fact, and this is a really important point to understand, we are not semantically changing the language at all. The IL, whether with question mark or without question mark, is identical to the way it was in C#7. We are only issuing warnings with one important exception. We are adding metadata to describe your intent, but we're not adding semantic checking in the IL. So what I mean by that, if in your API you go ahead and declare the parameter as string, not null, a not null string, meaning string without a question mark, and somebody invokes you and they're compiling with a C#8 compiler, and this feature is turned on and they pass you a string question mark or the value null, they will get a warning. And the reason they will get a warning, even though they're working against a library that you wrote and there's no semantic difference in the library that you compiled, is because we decorate the parameter with an attribute to say this is a not null reference type. And therefore, the IDE of the caller knows that it's not null, even though the semantic implementation of the compiled code is identical to the way it was, whether you had reference types nullable reference types turned on or not. And this is a really important point to understand about what's going on here, is we are not making any checks at runtime. We're not changing the code semantically at all. In fact, true story, it is quite likely that we will not update the .NET framework to reflect nullable reference types by the time we release C#8. That means if you work with console.readline, which cannot return null, and we don't happen to get round to updating that data type string to be string versus in string question mark, or whatever the other opposite way around is, it is likely that Microsoft will go ahead and allow you to add metadata files after the fact. So we can update API's intent, even though we didn't do it at the time we compiled the code. Because it is only metadata. We are not changing IL. Does anyone understand what I just said there? It is possible that we could go ahead and provide files on the side of your API that identify nullability of what the type should be, so callers will know what your API is intended to be. And if we make a mistake, we can modify the file, still without recompiling. Because there's no semantic difference in what we compile the code down to when we use nullable reference types. Yes?
So my question would be, why not?
Why not what?
At least when we have a public or basically a member that can be externally visible, why not add the type check, or sorry, the null check in front of it? Because like one of the things why we want that in the first place, that we can get rid of the checks for nulls of parameters, which is like the major security concern. And because of the decision of not providing the check at the beginning of the function, I can see how there can be a potential for a security problem in the downstream, basically, because you are assuming a lot of people, like, despite them, basically they will not hear you.
Okay,
right
so
now.
so the question is, yeah, but I want that feature. Right, I want you to do a nullable check. And I actually grant that request. Basically, you're saying the idea that I change the entire language from string to be nullable to now be not nullable is not a significant enough change enough. I'd actually like you to change the IL as well. Okay, just pointing out that it's a fairly major change as it is, and now you're asking us to change the IL. I'm not saying we shouldn't, I'm just saying it's not insignificant.
So I understand that reasoning, but then the problem is if you introduce it without it, and then you will not be able to later change the semantics because it will be changing the semantics in the future.
So the answer, so the request is a valid request. Just give me one more second to respond. Okay, go ahead. I'll delay my.
I would settle for one line of code that says, okay, look at all the parameters of my function, iterate through each one, throw argument out, some other exceptions for free for me, so I don't have to bother that code. I mean, it's so tedious. I mean,
Yes.
I mean, look at the majority of the code we write. Like this, like 2 parameters. They got 3 lines per parameter of if, blah blah.
Yeah. Okay, so the request is heard. It's loud. It's significant. The deal is, it's not good enough to just go ahead and tell you the intent. I want you to actually do the check, right? I mean, that's what you're requesting. So, if you take existing code today, it seems like it's quite possible that we have a lot of code today that does have problems. No, that is behaving correctly, as in gazillions of lines of code that is behaving correctly without this declaration. And then we go add it with a question mark, and now we change to go ahead and check for multiple times now. So every single time you call it, you've got your checker that already exists in your code, and you've added a question mark to go check it again, and that's now going to be happening all over. Whenever you've gone ahead and declared the question mark, you're going to be adding this. But I don't actually think the issue here is around whether we should or shouldn't. It's really an issue around how much work can we get done by the time that we do this feature, and turns out there's actually only so much money in the world, even in this campus. For lack of a better word. And so I think it is a valid request. I think it has been talked about. At this point, it's definitely not going to make it, but it is not precluded from making it in the future. And the most important thing, which I just relish being able to say this, it is open source. And you are welcome to go change it in any way you would so happen to choose. And that's totally unfair. But it is true, right? And at the end of the day, if you can get support for it, you don't even have to fork. And if you can't get support, you can fork it anyway and do whatever you like. No, I'm just kidding. That's not fair. My point being, I genuinely think that backwards compatibility is the most important thing. that's an extreme statement. Backwards compatibility is extremely important. And so there's a concern of saying, okay, if you add question marks, what is the effect on the behavior of your code that will break backwards compatibility?
I was suggesting I add one line of code saying check all parameters for null, equivalent, and then the compiler would expand that to my 3 lines of code for parameters.
Yeah. And then you go ahead and decide, well, I want you to check all the parameters except this one, and then, it's,
write it by hand.
yeah, I mean, it's like, we got to do a full feature here, otherwise we're going to end up like C++, right? We got to be careful. I'm sorry, was that my out loud voice? I genuinely think that all these things are valid, but I also think that we're sort of tiptoeing into this, and we need to proceed with caution. It turns out we do have precedents, right? TypeScript just did this. They went through this within the last year, and it worked out pretty well. So we are relying on the precedents that's happened with TypeScript, and we're leveraging that. And we've got a strongly typed language, so it's pretty good. So the key thing I want to make sure that everyone understands is, first of all, right now it is not we're not semantically changing the language. It's going to be compiled as is. We have the ability to go ahead and decorate a type as being allow nulls, because by default reference types don't allow null. The next thing you need to worry about is, oh my goodness, I got a million lines of code and I start compiling the C#8 and I've got errors as warnings, and I compile and my build breaks. And guess what? There's like gazillions of warnings all the way through my code. I'm like, oh my goodness, that's just too much, I'm going to turn it off. Well, that ain't much point in us doing all this work if you're just going to turn the feature off, right? So we got to think about this carefully. First of all, on existing projects that you upgrade to C#8, this feature is